Hey everyone, this is Miss Helms, and our final video of these problems involving the converse of the Pythagorean Theorem. So, this last problem is involving radicals. So, again, the same question is posed. We're trying to determine whether or not the triangle with the given side length is a right triangle. Now, with these problems, we always want to look for the longest side length because, as we've said before, the longest side length would be the hypotenuse if it is a right triangle. So when we look at these radicals, we may not know exactly, well, which is the longest side. So to help us out with this, what we can do is take each value and we can approximate it in decimal form. So we're going to say, well, what is the square root of 14 approximately? And if we put that into our calculators, the square root of 14 is approximately 3.74. The same thing with the square root of 30. The square root of 30 is approximately 5.48. So we have the side lengths, 3.74, 5.48, sorry about that, and 4. So looking at these three lengths, we know that if this is a right triangle, the longest side would be the hypotenuse. So therefore, this is our longest side of the triangle. So we're going to say, if it's a right triangle, this would be the hypotenuse. So just as we did before, we're going to use the Pythagorean Theorem to see whether or not the Pythagorean Theorem holds true with these three side lengths. So, since the square root of 14 and 4 are our two smaller lengths, we're going to use those as our legs. So the square root of 14 squared plus 4 squared. And we're going to ask, does that equal the square root of 30 squared? Okay, well, the square root of 14 squared is 14 plus 4 squared, which is 16. And we're asking, does that equal the square root of 30 squared, which is 30? When we combine our like terms on the left-hand side of the equation, we get 30 does in fact equal 30. So therefore, the statement holds true, which means these side lengths, the square root of 14, the square root of 30, and 4, do form a right triangle. Therefore, we have a right triangle. Nice work!